Hey kiddos, in this lesson 5.1, we're going to learn about algebraic expressions. Specifically, we're going to learn how to evaluate, which just means to solve, algebraic expressions given the values of their variables. A couple things that we want to keep in mind. When it comes to an algebraic expression, it's an expression that contains or may contain numbers, operations, and one or more variables. And the variable is just a symbol that represents one or more numbers. Each number or variable by itself or the product of a number and a variable in an algebraic expression is called a term. So in the example that we see here of 5p plus 4, 5p is a term and 4 is a term. Now the 5 that's in front of the p being the variable, is what's referred to as a coefficient. And the number 4, because it doesn't change, it's always going to be 4, that's called a constant. So taking a look at the example that we have here, where we want to identify the terms, the coefficients, and the constants. So 3 things. First off, what are the terms? When we're looking at 5p, the terms are, 5x and 13. Those are the 2 terms. What are the coefficients? Or what is the coefficient? Well, there's only one, because the coefficient is always going to be attached to a variable. And in this example, x is our variable, so that means 5 is our coefficient. And then finally, what's the constant? The constant is number 13. Because that's always going to be equal to 13. That's not going to change. Simple enough? Cool. Let's look at letter B. Letter B, we see 2z squared, or 2z to the second power, plus y plus 3. What are the terms? 2z squared is a term, y is a term, and 3 is a term. What are the coefficients? Well, we see that the variable is z. That means the number in front of the z, or being multiplied to the z of the variable, is the coefficient. In this case, it's 2. But there's another one. When we're looking at the variable y, how many y's are there? There's 1. Even though we don't see the number 1 there, we recognize and understand that that is a variable, so the coefficient is going to be 1. So a variable by itself always has a 1 as a coefficient. So 1 would be a coefficient there. And lastly, what's the constant? Well, the constant is the number that doesn't change, and 3 doesn't change. It's always going to be 3, so 3 is a constant. Now let's write algebraic expressions when there are exponents. An exponent is merely telling us, hey, this factor, whatever that number is, that's the base, is going to be multiplied to itself this many times. And when we look at A, how many letter D's, or how many factors is D? It's 1, 2, 3, 4. That means the exponent is going to be equal to 4. So our base is D, the exponent is 4, and we write that as D to the 4th power. What about letter B? When we look at letter B, what's the variable? What's being multiplied over and over again? Well, it's the letter H. And when it comes to the letter H, how many H's are there? There's 1, there's 2, there's 3. So that means the exponent is going to be 3. So H to the 3rd power. But is that it? Is that going to be an equivalent expression? No, because we have the number 1.5 that's acting as a coefficient, because we also have to multiply that by 1.5. So this expression, the equivalent, would be 1.5 times h to the 3rd power, and that's going to be our equivalent expression. I'm hoping you also recognize that it's multiplication between 1.5 and h, but we don't have to put the symbol there. It's understood that when you have the coefficient in front of a variable, that it's multiplication. Let's move on to number 3. Now we want to be able to evaluate, and evaluate just means to find or to solve that particular expression. And for letter A, we see that it says k plus 10 when k is equal to 25. So if k is equal to 25, and we're adding 10 to that, it's 25 plus 10. What's 25 plus 10? Yeah, you should have said 35. What about letter B? What does that dot represent? What operation is that? Should be saying to yourself, that dot means, that's right, multiplication. So we're multiplying 4 times n. And when it comes to this, 4 times n, you're going to see multiplication. Well, 4 times 12, n is equal to 12. 4 times 12 is equal to 48. However, you're going to see that this can be written, this multiplication can be written several ways. It can be written as, like we see here, 4 dot n, which means 4 times n, where the 4 and the n are right next to each other, where the coefficient 4, the variable n, they're right next to each other. Or we see the parentheses of 4 parentheses n. Each of those mean the same thing, which is just 4 times n. What happens, though, if we have two variables? Does that change it or make it more difficult for us to be able to evaluate? We can still do the same thing. When we're looking at A, we see the variable n and the variable m. Well, n is equal to 30. M is equal to 12. We're just going to evaluate and solve. What's 30 minus 12? That's right. 30 minus 12 equals 18. What about letter B? In letter B, we see that there's a fraction, 2/3. Is that difficult? Hopefully you're not going to get too worried about this, but if you are, take a moment, take out your composition notebook, write this note down. When it comes to dividing fractions and whole numbers, we want to remember 3 letters that are going to tell us to do 3 things to solve. First, keep the dividend exactly the way that we see it. So in this case, A is our dividend because that's to the left of the division symbol. All right, so 16 is not going to change. A is not going to change. C, change the division problem or division operation symbol to multiplication. And then last but not least, we're going to flip or find the reciprocal or multiplicative inverse of the divisor, which in this case is 2/3. So if we flip it, that's going to be equal to, instead of 2/3, it's going to be 3/2 or 3/2. And now, when we rewrite this as 16 times 3/2, well, we're just going to multiply straight across for our numerators and denominators. And if we have a numerator and denominator, that's just division still. And it should be a little easier to simplify. And in this case, 48/2, because 16 times 3 is 48. 2 times 1 is 2. So 48 divided by 2 is what? Oh, that's a little easier to work out. That's equal to 24. So that means 24 is the equivalent of 16 divided by 2/3. Alrighty? Great. Now that we've done that, we've done where there are 2 variables. Let's see if we can work it out with 2 operations, meaning addition, subtraction, multiplication, or division. We have this example here. 3x minus 14 when x is equal to 5. So x is equal to 5, great. So that we can substitute it into the expression. 3 times 5. 3 times 5 is equal to 15. 15 minus 14 is? That's right, it's equal to 1. What about the second expression? N squared, or n to the second power, that exponent 2. What does exponent 2 mean? It means whatever our value of our variable is, we're going to multiply it to itself twice. And in this case, n happens to be equal to 2. So 2 times 2, or 2 squared, is equal to 4. And then 4 plus 8.5, remembering that the decimal, since we have a decimal in this equation, in this expression, the decimal is behind the 4. So we could rewrite this as 4.0. 4.0 plus 8.5 gives us 12.2. Oh, 12.5. I apologize. So kiddos, with these examples, we're going to go through our classwork today, or any questions that you may have, please make sure you're checking in with me so we can get that squared away so that you are ready to go for today's lesson. Let's rock and roll.